Here's part one. We want to simply draw the ray for each angle. So 5 pi over 3, we're going to rewrite that as, first off, 10 pi to the 6th. This is going to make it easier to find. So we count by 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pi over 6. Next one, 11 pi over 6. So again, we'll count by pi over 6. So there is 9, 10, 11 pi over 6. So what I should see is this one is closer to the 270 mark, or 11 pi over 6, sorry, 9 pi over 6. This one is closer to the 360 mark, or 12 pi over 6. That's the accuracy we want here. Now this is negative 15 pi over 4. So we're going to count in the negative direction. We're going to count by fourths. So there's 1, 2, 3, 4. We're counting in the negative direction, and we're counting by fourths. So it should take us 4 of those to get around to pi. So there's negative 4, negative 5, negative 6, negative 7, 8, 9, 10, 11, 12, 13, 14, 15. So just keep counting around until you get to negative 15. It's okay if you count around the circle more than once. Now we want 2.22. This is a decimal radian. So here's the first one where we start to get to the in-between angles that aren't the normal ones that we're used to dealing with. So 2.22, we've got to find it. So to help find it, we need to set up some signposts. So because it is a decimal radian, we want to make sure that our signposts are in decimal radians. So instead of 0 and pi, we'll rewrite that as a decimal, 3.14. And this would be half of pi. So just divided by 2, 1.57. So now we want to say, okay, 2.22 is it in the middle, closer to one end or the other. So 2.22 would be somewhat closer to 1.57 than to 3.14. So we'll draw it up there. 800. Now, we could count around by degrees up to 800, do 360 and some more. I'm just going to go ahead and subtract by 720, which would be subtracting by 360 twice. And so I'm going to get 80 degrees. So really all I have to do is draw 80 degrees. So there's 90 right there. There's 0, so it's between those two, and it is much closer to 90 degrees. Negative 3. Again, we're in radians, but we're in decimals. So negative 3.14 would be pi. Here's 0. I know it's in between there. This would be negative 1.57. So it's in the third quadrant here, but it's much closer to negative 3.14. So there's my arrow. Now, depending on which version of the test you ended up with, you either had 5/3 or 1/2 here. I'll graph them both. But first off, notice there's not a pi. It's not 5 pi over 3. It's not 1 pi over 2. It's 5/3. So we would treat that as, say, 1.67, 1.6666 if you type it in your calculator. 1/2 would, of course, be 0.5. So let's find both of those angles. They're both in decimal radians, even though they're written as fractions. Think about them as decimals. So this would be 3.14 over here. We set up our signposts in decimal 0, 1.57 radians. So where would 1.67 be? Well, it'd be just a little bit past 1.57. Where would 0.5 be, or 1/2? 1/2 would be in the first quadrant, closer to 0. So again, there's 5 over 3, there's 1/2. 314 degrees. So we're working in degrees this time, so we want to set up our signposts in degrees. So a full circle is 0 or 360, and then 90, 180, 270. So where would 314 be? Well, it's between 270 and 360. Is it closer to one or to the other? Well, 315, you might remember, is right in the middle, and so 314 is basically going to be right in the middle. 22 pi over 13. This time we want to set up our circle, our signposts around the circle in radians, but as fractions of 13. So instead of pi, we'll write 13 pi over 13. And instead of, well, we'll still write 0. A full circle would be 2 pi, which would be 26 pi over 13. And then we know that 22 is between 13 and 26, so let's figure out where exactly it is. Halfway would be, what's halfway between 13 and 26? Let's see, add them together, 39, divide by 2, so 19.5 pi over 13. So 22 is going to be, we can see in the fourth quadrant down here, closer to 19.5 or 26. Well, it's 4 away from 26, and it's 2.5 away from 19.5, so I'm going to say it's closer to 19.5. 275 pi over 180. Here, we want to set up our circle in pi, but fractions of 180. So, of course, pi would be 180 pi over 180. Then a full circle would be 360 pi over 180. So essentially, you notice we're just counting in degrees. That's 180 degrees, that's 360. This would be 270 pi over 180. If you average 180 and 360, you'll get 270. That should be right in the middle. So 275 should be a little bit past that. So it's in the fourth quadrant, closer to the bottom. Okay, let's move on to the next round of questions here. Okay, so first off, number 11. So here we want to count by 10 degrees, and we want to know what that would be in radians. So first off, a quick reminder, when we counted by 30 degrees, we know that a half circle is 180 degrees. So if you divide 180 by 30, how many pieces do you get? You get 6. So there would be 6 pieces. Each one would be 30 degrees. So that would also be a sixth of pi, so we counted by pi over 6. Sixths of pi. Take pi, it's split into 6 pieces. Now, that's every 30 degrees. If we wanted to do that for every 10 degrees, how many pieces would we be splitting each of these 30-degree sections into? So to make 10-degree sections, we would split each 30-degree section into 3 pieces. Like that. Okay? So that would be every 10 degrees. So to figure out what that is, how many total pieces are we splitting this into? Well, there were 6. Now we're splitting each of those 6 into 3. So that means 3 times 6, there would be 18 slices. And so each one of those, since the entire half circle would be pi, each one of those slices would be 1/18 of pi, or pi over 18. Now, some of you set this up as a proportion, which would be great. So we know that pi over 6 goes with 30 degrees. So what would go with 10 degrees? So I set it up like that. So you start by cross multiplying. So 10 times pi over 6 equals 30 times x, and then divide by 30. The 30 reduces with the 10, and so again you'll get pi over 18. So same answer. There are a couple different ways to get it. Number 12, I'll let you read that. Number 13, 165, we want to find it. So here's 180, here's 90, here's 0, so we can see it's in the second quadrant, closer to 185. For number 14, we want a positive coterminal angle. So remember, for a coterminal angle, you either spin around the circle an extra time in the positive direction or an extra time in the negative direction, or maybe even 2 extra times. So you just add or subtract 360 until you get there. Here, let's add first, which would be 525 degrees. So that would be 165 plus another complete spin to end up in the same place, and that's what coterminal means. Let's find another one. 165 minus 360. So this time we're taking a spin in the negative direction. So go 165 degrees and then back up a full circle. And so you get negative 195 degrees. Now let's convert 165 to radians as an exact fraction. Don't forget to read the directions. Okay, so 165 degrees. Since we want to convert to radians exactly, we're not going to use 6.28. A full circle is not exactly 6.28 radians. It is exactly 2 pi radians. So we're going to use 2 pi over 360. So this way the degrees will cancel out. And now what we do, I'm going to go ahead and put the 165 over 1. You can even set it up like the train tracks thing that you do in chemistry if you want to. So the 165 is on top. We're going to see if we can reduce this somewhat. So first off, the 2 and the 360, that would reduce to 1 and 180. So then we would have 165 pi on top. Again, you're multiplying across the top, 165 times pi. And then on the bottom, 1 times 180. So 180. And 165 and 180, you might notice, are both divisible by 5. And so let's divide them both by 5. So 165, let's see, 150 would be 30, and then there's 15 more, so 33. And then 180 divided by 5 would be 36. And hey, look, I think I can do more. I can divide them both by 3, so that would be 11/12 of pi. There you go. Exact reduced fraction. Okay, so let's come back down the right-hand side, work 17 through 20. So 13 pi over 11. First, we want to draw that. All right, let me turn on some light. Oh, too bright. Somewhere in the middle. Maybe that's better. I can't tell. Okay, so 11 pi over 11 would be here. 22 pi over 11 would be a full circle. That's 2 pi. So halfway in between those, average them together, add them, divide by 2. 33 divided by 2 would be 16.5 pi over 11. So where would 13 be? Well, it's between these two numbers, so it's in the third quadrant. Closer to which one? It's 3.5 away from that, 2 away from that, so it's closer to 11 pi over 11. Now, we're going to do the same thing we did on 14 and 15 to find coterminal angles. We want to either add a full circle or add as many full circles as you want to. Here, let's add 1. So remember, 2 pi is a full circle. So this would be rotating 13 pi over 11 and then rotating a whole complete circle. So we're going to add 2 pi to add another circle's worth of rotation. 2 pi, of course, is 22 pi over 11. So we want to give them a common denominator. We'll add, that's 35 pi over 11. Now, to find a negative coterminal angle, we can subtract. So again, we'll subtract a full circle, so that would be going a positive 13 pi over 11, rotation, and then rotating backwards a full circle. So we'd end up at negative 9 pi over 11. One thing to point out here, it sure helps when you show your work. If you wrote down 13 pi over 11 minus 22 pi over 11, and then said, okay, it equals negative 8 pi over 11, I would at least know you did the right thing, and you knew what you were supposed to do. You just forgot how to subtract. Temporarily. That's okay. If you don't write anything except just the wrong answer, I don't know if you knew what you were supposed to be doing, or if you just made something up, or if you did the wrong thing. So it's wrong. So just make sure, even when it's just one step, show your work, show your knowledge. That's what the test is all about. Any knowledge that you have, put it on your paper. That way I know that you have it. And number 20, convert 13 pi over 11 2 degrees. So the 11 is going to go on the bottom because it's, well, on the bottom of the fraction. And then this time we want to use radians on the bottom so that the radians cancel. The pi also cancels here. And then 360 degrees on top so that we're left in degrees. So there's our conversion. So let's see if anything will reduce. I think that 360 and 2 will reduce to 180 and 1. So let's multiply this out and see what we have. Again, the pi's would cancel out here. So I get 13 times 180, which is 20, let's see, 2340. And then 11 times 1, which is 11. Side note, I don't have a calculator handy, so I did that in my head. If I did it wrong, don't think that you don't know how to do math. If you have a calculator and you get the wrong number there, you feel free to correct me. Okay, so that's number 20. That's the end of the first section.